For photoelectric emission from certain metal, the cutoff frequency is V. If radiation of frequency 2V impinges on the metal plate, what will be the maximum possible velocity of the emitted electron, where m is the electron mass? To solve this, we can use photoelectric equation, which is given by Kmax is equal to HF minus HF naught, where Kmax is the maximum kinetic energy of the emitted electron, H is Planck's constant, F is the frequency of the incident radiation, and F naught is the cutoff frequency of the metal. Here, the cutoff frequency S naught is nothing but V, and the frequency of incident radiation F is nothing but 2V. So, the maximum kinetic energy is given by Kmax is equal to H into 2V minus HV, which is nothing but HV. The kinetic energy of the emitted electron is also given by Kmax is equal to half mv square max, where m is the mass of the electron and v max is the maximum velocity of the emitted electron. Setting these two expressions for Kmax equal to each other, we get half mv square max is equal to hv. Solving for v max, we get V max is equal to square root of 2hv divided by m. So the correct answer is option B, square root of 2hv divided by m.